Alright, hello guys. Welcome to this next lesson of Engineering Principles Advanced. Today we're going to be talking about energy. So, Merriam-Webster's dictionary defines energy as a fundamental entity of nature that is transferred between parts of a system in the production of physical change within the system and usually regarded as the capacity for doing work. As you can see, I've underlined that last part, the capacity for doing work. Shows the relationship between energy and work that we talked about in the last course when we had our video on work. So work is the ability to do anything. It's the transfer of energy. But in order to be able to transfer energy, you have to have energy in the first place. So for the sake of this video, we're going to be talking about two main types of energy: potential energy, which is stored energy, and kinetic energy, which is the energy of movement. Underneath potential energy, there's a whole bunch of types. There's gravitational potential, spring potential, and others. But for now, we're just going to focus on gravitational potential. So when I say potential energy, what I really mean is gravitational potential. And to understand how these different energies work, let's just look at some examples. So right here we have a block on a ledge 3 meters off the ground. So most of you who are in middle school would be able to understand that, yes, that block has potential energy. Being above the ground gives it potential energy. But what you might not know is that the mass of the block actually also plays a role in the amount of energy that it has. So we can see that in the equation for UG, or gravitational potential energy. That's how we write gravitational potential. UG equals mgh. So in this equation, UG is the gravitational potential energy, m is the mass of the object in question, g is the gravitational constant, or the acceleration due to gravity on Earth, which here is 9.8 meters per second squared, and h is how high off the ground the block is. So knowing all of this, we can actually solve for the UG in this situation. So UG equals, lost the font. Let's try this again. All right, we're just going to go with it. UG equals M, which is 3, times G, 9.8, times H. Oh, sorry, did I say 3 for M? I meant 1, times 9.8 times 3. So we get a UG of, let me plug that in real fast, 29.4. 29.4, and the unit for energy, if you remember from last time, is joules. All right, so that's how we find the gravitational potential energy of an object. Now let's move on to kinetic energy. Any object that's moving with a certain speed has kinetic energy. If it crashes into something, it'll give that other object its kinetic energy. It'll do work on the other object. So to solve for how much kinetic energy an object has, we use this equation over here. K equals 1/2 mv squared. K being kinetic energy in this situation, 1/2 being just a coefficient that we use, m standing for mass of the object in question, and v squared being the velocity squared. So the velocity has a greater impact on how much kinetic energy an object has than the mass of the object. So using all of that information, we can solve this next problem. K equals 1/2, not 2/2, 1/2, m, mass of this box, slightly bigger than the last one, 2 kilograms, times v squared. Now the v in this situation is also 2, so it'd be 2. Use the caret sign when we're not actually writing with exponents. The caret sign represents to the power of 2 to the power of 2. That's a lot of 2's in that problem. So we can then go to our calculator, plug that in, and we get 0.5 times 2 times 2 squared gives us a kinetic energy of 4 joules if we did everything correctly. And so that right there is how much kinetic energy this box has. So if it, let's say, crashed into another box and transferred all of its energy, it would be doing 4 joules of work on the other box. So hopefully that helps you guys understand energy a little better. On the two different types of energy, we may be using this later when we're talking about mechanical advantage. So just keep it in mind for then. Thank you.